You edit one line on a remote server, restart SSH, and your terminal freezes. The web app still runs, but you cannot log in to fix the typo. That is the nightmare sshd config teaches early. Today we build the habit that prevents it. Install the openssh server, understand the file that controls it, test before touching the live daemon, keep your current session open, and reload instead of restart. If you own Linux servers, this is not theory. This is the door you use when everything else is broken. SSHD config is the server-side policy file for OpenSSH. Your SSH client has its own config, but this file belongs to the machine accepting logins. It tells SSHD which address and port to listen on, whether root may log in, whether passwords are allowed, whether public keys are accepted, and whether only certain users can connect. On Debian and Ubuntu, the package is OpenSSH Server. On Fedora, RHEL, Rocky, Alma, and similar systems, it is also OpenSSH Server, installed with DNF. After install, systemd manages the daemon. Your job as an administrator is to make policy explicit, small, tested, and recoverable. When SSHD starts or reloads, it parses /etc/ssh/sshd config. Many distributions also include files from /etc/ssh/sshd config d, usually with an include line near the top of the main file. Order matters. In OpenSSH, unless a directive documents different behavior, the first value obtained is the one used, which surprises people who add a second password authentication line later. Match blocks are another scope change. Settings after match may apply only to a user, group, address, or other condition. Our big 8 for foundations are port, listen address, PermitRootLogin, PubkeyAuthentication, password authentication, KBD interactive authentication, allow users, and match. Walk this card slowly. On Debian or Ubuntu, run apt-update first if your package lists are stale. Then install OpenSSH Server with apt. On Fedora family systems, use DNF. Next, change into etc SSH and make a simple backup of SSHD config before editing. That backup is not fancy configuration management, but it gives you a known, local rollback. The last line is the habit. Sudo sshd-t validates syntax and host key sanity. Only if that succeeds does systemctl reload SSHD run. Some Debian and Ubuntu systems name the service SSH, so use systemctl reload SSH there if SSHD is not a known unit. Here is a common first hardening pass for a small server you administer. You already created the admin and ops accounts, and you confirmed both can log in with keys. Now keep your current SSH session open. In a second terminal, edit sshd config. PermitRootLogin no blocks direct root login. Use a named account and sudo instead. PubkeyAuthentication yes keeps key login enabled. Password authentication no disables normal password login. KBD interactive authentication no closes the keyboard interactive path, which can otherwise still reach PAM-backed prompts. Allow users admin ops makes the allow list explicit. Save, run sshd-t, reload, then open a brand new login before closing the old one. The first mistake is editing SSH through your only session and closing it before testing a second login. Do not do that. The second is restarting when reload is enough. Reload asks the master daemon to reread configuration without disrupting established sessions, and it avoids a listening gap. The third is duplicate directives. A drop-in file may already set a value, and your later line may not win. Use sudo sshd-t to inspect effective configuration when you are unsure. Fourth, match blocks continue until the end of file or another match, so keep them at the bottom. Finally, SSHD config is normally root-owned and readable, often mode 0644. Private host keys must stay private, usually 0600. This episode sits between client basics and real server hardening. SSHD config decides the policy, but it is not the whole system. Public key login also depends on users, home directories, authorized keys files, and permissions. Root login policy connects to sudo design. Password policy connects to PAM. Detection connects to journald, auth logs, and patterns like repeated failed authentication from the internet. Later in the series, we will break those out one at a time. For now, the foundation is simple. Know where server policy lives, change one thing at a time, validate it, reload it, and verify from a fresh session. 5-minute practice on a machine or VM you own. Install OpenSSH Server with apt or DNF. Open one terminal and SSH to the machine, even if it is just from your host into a local VM. Leave that session open. Backup/etc/sshd config. Edit one harmless line, such as adding a comment with today's date, or explicitly setting PubkeyAuthentication yes. Run sudo sshd-t. If it passes, reload the service. Then open a second SSH session and confirm it works. Only after that, close the original session. You are training the muscle memory that prevents remote lockouts. 3 beats to remember. First, sshd config is server-side SSH policy, usually at etc ssh sshd config, with possible drop-ins under sshd config.d. Second, install openssh server with your distro's package manager, backup before editing, and run sshd-t before any reload. Keep an existing session open, prefer reload over restart, and verify with a new login before walking away. Tomorrow we keep building from foundations toward production-grade administration and defense. New SSH episode daily on this channel, from zero to expert. Also daily, the ranked CVE brief, so you know what actually needs attention.